Detect loop in a linked list. Let's find out how to answer this question in a technical interview. To begin with, you can draw a linked list on the whiteboard. A linked list has nodes which are connected to each other. Each node has two components, the value and the reference to the next node. The head node points to the first element of the linked list. If the linked list does not have a loop, then the last node will point to null. Whereas if it does have a loop, then it will point to some other node within the linked list. The first solution that comes to mind is if we can somehow mark the nodes as visited. So we loop through the linked list and we keep on marking the nodes as visited, and if we see a visited node second time, then we know that there is a loop in the linked list. The problem with that approach is we don't have such a Boolean flag on each and every node in the linked list. As I mentioned, each node has only two properties, the value and the reference to the next node. So if we were to create a special linked list where each and every node has three properties, including this Boolean flag, then our solution can work. As you can imagine, this might not be the best answer. The second solution that comes to mind is if we can store all the nodes in another data structure like a hash set. So we keep visiting each and every node, and as we visit them, we check if the node previously exists in the hash set or not. If it does not exist, we add it to the hash set. If it does exist, then we know that there is a loop in the linked list. This is how the pseudocode will look like for the hash set based solution. You might want to pause the video if you want to look at this algorithm. The runtime complexity of this solution is O of n, where n is the number of nodes in the linked list. However, there is also a space-time complexity of O of n, where n is again the number of nodes in the linked list because of the usage of hash set data structure. As you can imagine, this might not be the best solution either because of the space-time complexity of O of n. The most optimal solution to this question is similar to another question that I have discussed before called finding the middle element in the linked list. I'll be posting the link to that video in the video description. The solution is easy to understand. You have to use two pointers. One is called the slow pointer and the other is called the fast pointer. The slow pointer moves at a regular speed, that is, one node at a time, whereas the fast pointer moves at double the speed, that is, two nodes at a time. If at any point the slow pointer and the fast pointer point to the same value, then we know that we have detected the loop. Whereas if the fast pointer reaches null, then we know that there is no loop in the linked list. As you can see, initially both slow pointer and fast pointer point to the head node. After first iteration, the slow pointer points to the second node, whereas the fast pointer points to the third node. Then, after the next iteration, the slow pointer points to the third node, whereas the fast pointer points to the fifth node. Then, after the next iteration, now the fast pointer is pointing to the third node, whereas slow pointer is pointing to the fourth node. And now, after the next iteration, finally, both the pointers are pointing to the same node. So, we have detected the loop. This is how the pseudocode might look like for the solution that we just discussed. You might want to pause the video and check out the solution. I can understand if you don't want to pause the video because you are enjoying it so much. Well, if you want to check it out later, I will be posting the links to the pseudocode as well as the actual working solution in the video description. The algorithmic runtime complexity of this solution is O of n, where n is the number of nodes in the linked list, whereas the space-time complexity is just O of 1 because we are not using any other data structure. I will recommend you to practice writing the code on whiteboard as well as your favorite compiler. When you write the actual code in the interview, please make sure to take care of all the edge cases. If you follow all these steps, then I would say that you have successfully answered the interview question. I'll be posting more such interview questions and their solutions in my upcoming videos. So please don't forget to subscribe to my YouTube channel. Until next time, happy coding!